All right, we're going to study areas of triangles and quadrilaterals. This is the very last section of this semester. This is the section 6.7. I'm going to reiterate that this section will not be on your semester final, but we will be on next semester's final because I will be putting it. When you come back and you're doing your problems, this part will be on the review sections. Okay. All right. You have a note sheet that looks similar to this. Mine's in color. Yours is not. At the bottom, I didn't put on the bottom of yours. It says other formulas. You can write that if you'd like. You can write that eventually. We won't get there till a little while. But so we're going to talk about how to find the area of each of these shapes. These are not going to be in your postulate books. You're going to have them in your heads.
Oh, woohoo.
Right? All right, before we start, you do not have to write this down. I just need you to watch this. I need you to understand something. The area of a square is going to be the length of its sides squared. I don't usually memorize that one because in a moment you're going to learn that a rectangle is length times width, or they call it base times height, base times height, which is the same as length times width. And a square is a rectangle. So I don't like to memorize two different formulas for the same thing. So I just always remember that a square is base times height or length times width is the same. You could just, if you wanted to, you could just know that. If you have the side, it's going to be the same as that one, right? Because it's an S. It looks like a 5. I'm going to say base and base. So it would be base squared. Would be the area, okay, which is the same as base times height. Another thing you need to realize whenever we're doing area, that two polygons are congruent. If they're congruent, they have the same area. I hope that seems somewhat straightforward. If they're the same shape and size, they should cover the same space.
Wait, what's the polygon look like?
So any polygon, if I had two rectangles that were the exact same size and shape, they would both have the same area. Okay, so if I had two hexagons, and they were congruent to each other, they would have the same area. Okay, all right. I also want you to know that if you had some strange, I don't know if strange is the right word, a shape that you could break into pieces, if you could find the area of each of the pieces, if I found the area of the top one, and I found the area of the middle one, and the area of the bottom one, and I added them all together, that would be the total area. Okay, so that's basically saying the area of the non-overlapping parts. The sum of the areas of the non-overlapping parts equals the total area. Okay, so each of the little pieces equals the whole. All right, let's get down to some formulas. This is the formula for the area of a rectangle. There's not much for you to write inside of that thing. We might draw some lines here and there sometimes, but you can write it right inside of your picture. We've talked about it before, but you are used to saying length times width, and I always make my L's cursive so they don't look like ones. You can call it length times width. It's not going to be any big deal. Make sure your B and your H are lowercase letters. Don't put them uppercase letters. Okay. Next one is area of a parallelogram is also base times height. We're going to talk about that with a picture because the height is found a little differently than with a rectangle, but we'll show you that in a minute.
Oh, yeah.
Okay.
Yeah.
I want you to notice something. There is another parallelogram on your page down there. Where's the other parallelogram?
The trapezoid. No,
that one. What is that one going to be? A rhombus. So if
or
you
is that a kite? Because that looks almost longer.
Well, this is the kite. That one is intended to be the rhombus. Okay. All right. So you can use this area equals base times height for a rhombus. There's going to be another formula in case you have something different. Okay. Some other information. Area of a triangle is similar in the sense that it has a base and height, but it's half base times height. We're going to draw some pictures so we can find those bases and heights. All right, here we go. Rectangle, we have base and height. Your base and height are always going to be perpendicular to each other, okay? Rectangles automatically are perpendicular, so no stress. But a parallelogram's height is different. It's not the length of the side. It is the perpendicular distance from one of the bases down to the other.
Now for this one, this side though, we would have to draw it out. Correct?
Yes.
But
So over here, that's exactly right. On some of your problems, they might do this. Your perpendicular, if I extend that out, would be bad.
Wouldn't they also do a dotted line for the base
They would.
line?
They would. And so that is the same distance over. These two distances are the same. Those heights are the same. Questions about that? For a triangle, it's the same way. The height is the perpendicular distance down. Sometimes it will be like that parallelogram. It will be outside if it is a obtuse angle. Okay, we'll do some problems like that together. So it's not the length of a side. It could be the length of a side for a triangle though, if you had a right triangle.
Yeah.
And they told you could have this be your base and that be your height because it is perpendicular.
Perpendicular.
Okay.
That makes sense.
Questions? Yes. Okay. You could ask me because I can always do that.
Oh, okay.
All right. Here we go. There's some more formulas. Keep going. Here's the area of a trapezoid. It's 1/2 the height times the sum of those two bases. Those B1 and B2, please put the numbers, those are called subscripts. They're down. We're not squaring. It's a subscript. That means we're taking the length of one of the bases and adding it to the second base. Will it matter which base I take? It will not, because I'm adding, and adding can go in any direction. The next one is a kite. 1/2. D stands for diagonal. It's one of the diagonals multiplied by the second diagonal. The cool thing is a rhombus has some similarities to the kite. It has the same formula. 1/2 one of the diagonals times the other diagonal. I want you to know something. A square is a rhombus, a rectangle, and a parallelogram. So you can use the formula for the rectangle parallelogram is the same one anyway. But you can also use the rhombus formula for a square if you knew its diagonals and didn't know its sides.
Oh, yeah.
Okay?
I'd much rather just know its sides.
But if you don't know the sides, if
Yeah,
that information is not given and you know the two diagonals, and in a square that both of the diagonals are congruent because it's a rectangle and that's one of the properties, so you would just square the diagonals and have a half the squares. Okay?
Oh, yeah, sure.
Okay. All right, so let's get the pictures here. Again, the height of a trapezoid is going to be the perpendicular distance between the two bases. I need to put that it is perpendicular there. What do you know about the diagonals of a kite?
Don't they intersect perpendicular?
They do.
Or bisect or whatever.
They bisect. Well, they don't bisect each other, but they are perpendicular. It actually does bisect one of them. And then a rhombus. They're also perpendicular to each other, and the diagonals are those, the lengths of those. Okay. The diagonals of a rhombus do bisect each other because it's a parallelogram. So they would only have to, on a rhombus, they would only have to give you this half. Let's if that was like maybe a 4, and they could give you that one as a 3. You could then know that this other half over here was 3, and this other half down here was a 4 because it bisects. Okay. We just talked about some perpendiculars. They don't have to give you everything. They could give you 2 of these pieces and ask you to find this other part of the diagonal. This is a right angle. What the other formula at the bottom would they be giving you would be what you use,
Pythagorean.
the Pythagorean theorem, and we'll write that down in just a bit if you don't want it, or you could do it now. All right, we're going to do an example here with that exact equation that we're going to use, that Pythagorean theorem that we talked about, which is the a squared plus b squared equals c squared. This is on the very first question on 6.7. Is this a kite or a rhombus?
Kite.
It is a kite. It's longer than it's one of the diagonals is longer. So it's a kite. Actually, it is longer, but I mean it doesn't bisect it. In a rhombus it is longer too, but it's a kite. Okay. So I always, you don't have to do this. I always write, I do. You can highlight, underline it if you want, but I circled it. I always write the formula 1/2 d1 times d2. If you, maybe you've noticed ever since you've been writing that memory verse over and over and over, you actually are learning it by writing it all the time. If you write that formula over and over and over, you're going to know it better. And we're going to have to, second semester, you're going to start having to memorize your formulas. Instead of you having quizzes over and matchings over your postulates, you're going to have quizzes over your formulas. So that's going to change a little. So there, we started here. All right. What is one of the diagonals? How long is it?
12.
Yes. What about the other diagonal?
12.
Yes. Let's make sure we know why. This distance 6 plus 6 is 12. And this distance 2 plus 10 is also 12. What is 12 times 12?
144.
So you can have half of 144. Half of 14
Oh, yes.
is 7. And half of 4 is 2. So we got 72. Now, I'm going to pretend for a quick moment, because we need to talk about this. If this 6 was in inches and everything else was in inches, we would not be finished, because area always has square units. So I would have inch squared. This is not what you have to write on this particular one because there's no units. The answer for us is just 72. But I wanted you to make sure you realize that if they gave you units, you'd have to give you units squared. Yes, ma'am.
Could I have done the Pythagorean theorem with the 6 and the 10?
Yes, you could have. But the formula that we have for a rhombus, for a kite, uses the diagonals anyway. And so we wouldn't need the length of those sides. You would have been finding this length here.
Okay.
And you didn't need it.
Okay.
Does that make sense?
Yes, ma'am.
Okay. We will be getting to one in a little bit that you will need. Yes, we will need it. Okay. All right, let's do this one. Number 2, is that a kite or a rhombus?
Rhombus.
I'm going to change colors. All right, it's a rhombus. And I like green better. All right. What's the area formula for area?
Half d1 times d2.
Yes. All right. What is one of the diagonals?
8.
Yes, we got that from here. 4 plus 4. And the other diagonal?
10.
I want you to notice that because this is a rhombus, it bisected, so I had 2 of the same numbers twice. That will always happen on a rhombus. 10. You can do this a couple different ways. You could take the half of the 8 right now and make it 4. You'd have 4 times 10.
Mom, is
Or-
it okay if I wrote mine that way?
Yes, if you can. Or we could take the 8 times 10, make it 80, and take half of 80. Both ways we'll get 40 as our answer. Okay. Questions on numbers 1 and 2? Well, I think we're going to skip a little bit. Let me see what we have next. I can't remember. No. down at the bottom, I want you to just look at number 5 on that page you were on.
Yeah, that's what I was...
It says to use the Pythagorean theorem.
Well, I can't tell whether it's a kite or a rhombus. Because to me, it looks like a rhombus, but it doesn't
Yeah,
tell
they
me.
don't tell you. I'm going to tell you right now that number 5 is a rhombus.
Okay, because on the
They didn't make
previous
marks on it.
lesson, we had several kites that looked almost like a rhombus.
Yeah. So it's a rhombus. They didn't give you a diagonal, though. So you're going to have to use the Pythagorean theorem.
Okay.
And you'll need to know that all of those sides are equal, so it's a 50, okay? And if you memorized your Pythagorean triples from last time we talked, do you remember what the Pythagorean triple we talked about last time?
3, 4, 5.
Yes.
So wouldn't it be 30?
Yes. It's because it's 40 and 50, so the missing piece. Let me get a blank. Okay, so I'm going to have to draw that rhombus because I don't have it on here. They gave you 40 here and 50 here. We need this piece right here because we know this is 40. So this
No, the diagonals don't bisect each other. Oh,
yes, they do. So right here, we can call that like X. Since you guys memorized the 3, 4, 5 triangle, which one of those is the hypotenuse? Or the
50.
The 5, yes. And since I have 40 here and 50 here, I could jump to that answer really quick without using the Pythagorean theorem if I wanted, and just make that be a 30. If you want to do the Pythagorean theorem, you'd have x squared plus 40 squared equals 50 squared, and that would be x squared plus 1600 equals 2500. Subtracting that over, I'll slow down.
That's so cool.
So the x squared will equal 900 after you subtract. And the square root of 900 is 30.
So cool.
So if you memorize your 30, 60, 90, no, that's wrong. Your 3, 4, 5 triangle, that's a Pythagorean triple, it would have saved you a lot of time doing all that because it was 50 and 40, so it had to be 30. Okay? All right?
That's kind of cool.
Number 6 is going to have another Pythagorean triple that you don't know yet. So once you do number 6, if you just realize when you have that 13 and that 12 there, the other one is going to be a Pythagorean triple that I'm going to have you memorize second semester also. And so you'll just be on your way there if you'll just kind of start trying to remember that one. Are there any questions about number 5? The answer is not 30, by the way. The answer is not 30. This right here is 30. Oops. And 30. So you still have to find your area by doing your 2 diagonals. Do you want me to do that with you?
Yeah.
Let's do it together. Okay.
Okay.
All right, I'm going to get a highlighter out here. How long, I'm going to ask this for you, Josie. Right here, I have this diagonal. The top piece is 30 and the bottom piece is 30, so how long is the whole thing?
60.
Very good, 60. So I'm going to put a 60 in there. All right, Heidi, I'm going to ask you this one right here. How long is that second one I just drew?
80.
Very good, 80. You have multiple ways you can do this. You can just put it in your calculator and just one fell swoop hit enter at the end, or you can do it in multiple pieces if you'd like. Okay, I think I know what that one is. We got a 24 with some zeros. How many zeros do we get? 2, 2400? Okay. We're not finished when we have 2400 on this one.
What?
Would you? Not
No,
plus.
I'm sorry, not plus.
There you go. Let's multiply.
Yeah.
Yeah, you got it. It's okay.
Whoopsie. I was like, what? I got 70.
We're not finished even yet. We're almost there. What do we need to do on this one still?
inch square.
Yes, they gave us the units on this as being inches, so we need to write inches squared. I'm going to make this a little smaller so that I can fit it. All right, 2,400 inches squared.
Wow. Okay then.
All right, questions? All right, let's move on to number 7. This is a triangle. How do I find the area of a triangle? What's the formula?
Half base times height.
Yes. How about, can we see that? You guys can't see that very well. Let's do a darker color. All right, so we have 1/2 base times height. That's the area. I've got a base of 7.2 and a height of 7.3. I need my calculator.
It doesn't matter which order I put them in, right?
No, it doesn't, because we're multiplying, and so technically the base is different than the height, but multiplying it's going to be the same answer. I got 26 point something. What'd you get?
2.8.
Yes, 26.28. We're not finished.
That's what I got as well.
Yard square.
Very good. I wanted you to see number 8, how it has a, its height is different. The height, because that was an obtuse angle, the height has to be out here. It's still the same formula. 1/2 base times height. We still do the 1/2. The base is 3. And the height is 4.3. You can just do that in one. I actually think that you're going to be more accurate if you do that in one fell swoop on your calculator as opposed to putting it in and writing it multiple times.
Oh.
You might write the wrong number down. You might, I think you're going to have less buttons to push, so less
Okay.
wrong buttons to push.
Yeah.
So, especially so you guys have the screens where you can actually see after you're done what you put in.
Yeah.
6.45. Is that what you got? And
ma'am.
and would you get? What's the units?
Kilometers squared.
Kilometers squared. All right. Looks like a capital K.
Yeah, so does mine.
All right. Let's move on from triangles. We're going to move down. You have some more triangles to practice on yourself. We're going to jump now to 14. 14 is a square.
Yeah, they don't do any of the squares where they just give us diagonals. Thank heavens.
It would be the same as you just multiply the diagonals
And
against the
true.
rhombus, so it would be pretty hard. This one, you can use the formula that you just square it, or you can use the formula base times height,
Less to write if you just do the squared.
I suppose. Since it's the same thing twice, we could just write 6.8 squared. That's a decimal, even you can't hardly see it. There we go.
That 4 looks so off.
.24. Okay.
That's what I got as well.
Meter squared.
Meters squared. Good job. Don't forget to put the squared on there. We have another rectangle. 14 was a rectangle. We're also now moving over to keeping up with rectangles here. Area equals base times height.
Oh.
5.9 times 11. That's going to be 646.16. I don't know. I'm doing it in my head. And yes. Oh, 649. Yeah.
What?
I didn't put 64.9.
Yes.
Okay. I didn't put the decimal in.
I'm like, where is? Where is something different?
But I need to put the centimeters squared. All right. Let's jump to 23. Turn the page.
It's on the same page as 19.
Oh, it is. Okay. All right. Here we go. I wanted to show you, most of the parallelograms that they're giving you are going to look, they're going to have the heights be outside. I think they can draw them easier, that's why, on their drawings. But they don't always have to be.
Through 30, isn't it?
Even on...
Or 27 through 30.
But those are trapezoids.
Oh, yeah,
so,
that's true.
Yeah. So when they're given parallelograms, they're going to be doing it this way. So it's the same formula. Area equals base times height. We just multiply the two numbers. 10.9 times 6. And what'd you get, Heidi? I haven't put my calculator yet.
65.4.
Okay, all right.
Miles.
I had somebody
That's
else
what I got as well.
agree with that. You said 65.
5.4 miles squared.
Miles. It's miles, and we have to put a squared on it. Okay, good. I agree. Second one. These so far, this assignment will have no algebra on it. We'll just be doing multiplying some things together, sometimes taking half of it. We might be doing Pythagorean theorem in a sense. I guess that is a little algebra. All right. So we've got base times height. 2.2 times 8. Ooh, I'm running out of room. Yes, miles squared. Okay, fantastic. Questions about any of these? Right. Too bad this isn't your final, huh?
Yeah.
Okay. All right, let's move on. Trapezoids, this is your longest of your formulas, okay? Your longest of your formulas.
Yeah, what was...
Good question. That's exactly what we need to do. Area equals...
Oh, yeah, 1/2.
1/2
Height times B.
height, B1 plus B2. Okay, so we're going to just take the height, that's the 5.1, put it in the place of the height. Which one do I pick first? Which one's B1 and which one's B2?
Doesn't matter.
It does not matter. Does not matter. 2.9 plus 9.1. Now, those of you who have these sophisticated calculators, you can just write it just how it is. 1/2 times 5.1, open parentheses, 2.9 plus 9.1. And then hit enter once at the end.
Oh, could have. Whoops.
I have to do this part over here first. I have to do the 2.9 plus 9.1 first.
Because you have the...
Yes. Then I multiply by 5.1, and then I divide by 2 at the end. So I'll do 2.9 plus 9.1. Hit enter first. I'll multiply that by the 5.1, and then I will divide by 2 instead of multiplying by 1/2. And I got 30 point... And you guys got 30 point... Yes, 30.6. That's what I got. Okay.
Feet squared.
Yep, that's what I got as well.
Okay, fantastic. I'm going to let you guys try that one by yourself.
Which one? 29?
This next one.
Oh, whoops, I was on 28.
Can you do 29? Let me know.
can use mine too if you want, Josie. I don't mind. Just let me know.
Crazy, I don't have enough room for all this. All right. 4.3 plus 9.3. Confirm your equation with me. Make sure you've done that correctly. Before you do go too far, just make sure you have the same formula. Plug everything in right.
Is that a 0.3, 4.3?
Yeah, my decimals aren't. They're showing up on the screen over here, but not up there very well. There we go.
Okay.
Okay. All right, when I put that on my calculator, I don't need you to show me the steps. I only need you to have really two things. If you want to write the formula, that's optional. I would suggest that you write it over and over and over. It'll be in your head very fast. But I only need you to have everything plugged in so that I see that you know how to plug things in. And then I need the answer. If you don't want to, show me all the steps underneath, that's fine. I don't need them. I got 61.2
meters squared is what I got.
Meters squared. But I need to have this highlighted section. I need to have a plugged-in formula and an answer. If you want to give me more, that's fine. Please don't give me less. All right. I want to talk about something up here. If I want you to look up here, I'm going to send home this with you. I meant to put it online for you to print. I'm going to pause and do that right now. You guys, ladies. All right. You should have this in front of you, and I'll be putting it inside the Dropbox for your parents to download for anybody who's not here today and watching this at home. And so I want you to just look up here if you can pay attention with me. These formulas that we talked about today will be given on a Formula Madness quiz, and you need to memorize them. Right now I have given you a sample of what this quiz will look like, okay? They'll have the words inside, and you will write them inside if the formula is inside. You do not have all of them today. You have only some of these, and second semester will be giving you more of these. So this is what I'm giving this to you so that you can write them in as we go, okay? And I'm giving you these. I'll give you a blank one that you can put inside, one that's mixed around differently. Well, they'll be the same ones but in a different place. I'll give you a second one. If you look at the bottom, it says level 1A. There's going to be a level 1B. It'll just be the same one all mixed around, and then a level 1C will be all mixed around. And so the level 1B, you can practice, get it out and practice, and see which ones you get right. Then when you come here, you'll take that here, and it'll be the same ones, just in different places. Because I don't want you to memorize where they are. I want you to memorize what they are, not where they are. Okay? Questions about this? This will not be anything you'll have to have memorized before you come back. It's just we're getting started with bunches of formulas right now. So here we go. Okay. All right. Let's just review really quick what we did this lesson. So if you'll get that review sheet, that note sheet out for me.
If I don't do that, I don't think I finished the page.
I understand. All right. So you have base times height. Area equals base times height for this one. Area equals base times height for this one. The height is a little different because it's the perpendicular distance. And it could be out there.
Question.
Or it could be in here.
Question.
Yes, as long as it's the perpendicular distance.
The bases on that are technically interchangeable, right?
That's correct.
So couldn't...
we
could do... Okay, so we could
you
do it that
could
way. We
do
could
it-
do it upside down.
Yes,
like
and
that.
they could give it to you like... Oh, come on. If I turned it like that, it could be like the... back up. It could be... They could also give you the perpendicular. It would be kind of difficult. But depending on how this thing's sitting, they could give you the perpendicular distance that way.
Oh.
And then this would be the base.
Yeah.
Okay? So you just need... It's whatever the perpendicular is to. So if it's the perpendicular to that one, then this bottom one down here is the base. Okay? All
So
right.
if you had to draw the perpendicular one, if you didn't want to do it out on the other end, you could just go up?
You could go straight from here down.
Oh.
It wouldn't really matter. It's the same place as this one.
Oh.
It's the same thing.
Oh, okay.
All right. So triangle is 1/2 base times height. The height's perpendicular distance again. We have a trapezoid. Sometimes the perpendicular height could be the trapezoid itself. If your trapezoid was a right trapezoid, it looked like that. Okay. We have same formula for your kite as for our rhombus. Your diagonals look similar. And the formula that was the other formula at the end was the Pythagorean theorem. The only thing you would have to do some kind of algebra with is, but most likely they'll have you do that on your kites and your rhombuses. Okay? Although you could do it on other things. All right.
Would they maybe need us to do it on like a right triangle?
They might have you do it on a right triangle. They could. Yeah. All right, you're going to use the appropriate formula to find the area for each figure. Make sure you show your work. I talked about that already. And don't forget to include your units when you're doing that. All right.
Sweet.